So the uses of the generator effect may be the hardest bit. Essentially, these are two things that we use to generate electricity. We can use an alternator if we want to generate alternating current. We can use a dynamo if we want to generate direct current. Now, there are three things that happen for both of them, and then it's either the alternator or the dynamo. Alternator, less complicated, but I'll go through these things. So the first thing that happens is the coil of wire. This thing here is supposed to be not just a single loop, but a whole coil of wire. And here for the dynamo, these coils of wire cut through the magnetic field lines of the permanent magnet they are in. These are different to motors. They don't have a battery. It's not turning. We are turning it, right? You would turn this in order to generate electricity. Yeah, and often you can tell because they've either got an ammeter attached to them to show currents being produced, or they might have a kind of bulb or something, but there's no cell, there's no source of power you're turning them. You've got to be careful. If it's something that's moving, it's a motor. If it's something that you're turning and it's making electricity, it's a generator. So when the coil cuts through the field lines, because it's moving relative to the magnetic field, you could move the magnet, you could move the wire, it would do the same effect. A potential difference is induced at the ends of the wire. If there is a complete circuit, a current will be induced in the coil, and there is almost always a complete circuit. We're really careful to use the terms potential difference induced. Then if there is a complete circuit, a current will be induced. Now, if you have an alternator, it's quite straightforward. You just turn it around. You have little brushes here, so these things are called brushes. And some little sort of like hoops, because what you don't want to do is get the wires all tangled up as you turn it, and then out you get a beautiful alternating potential difference or an alternating current, so going both ways, right? One complete turn would be one kind of cycle of that'll be one complete turn of the coil. Now, if though you want to create direct current, it is a bit trickier because every half turn, so for these bits, you need to reverse the direction of the current. And so what comes back is the good old friend, the commutator. And also there's brushes here. And the commutator, every half turn, the commutator switches these contacts, which means the direction of the current induced or the direction of the induced potential difference doesn't reverse. So the output for a dynamo looks like this. It still does this up and down. It's not a beautiful direct current. It still goes up and down because actually when it's perpendicular to the magnetic field, that's when you get the maximum, and then this 0 bit is when the coil is up here, so it's not perpendicular to the magnetic field, may not even be in the magnetic field anymore, so you get no current produced. If it was a cell, if we were talking about just like a battery, the graph would look just like this, just a kind of straight line up there, maybe a 1.5 volt direct current cell. But this is what it looks like for a dynamo, right? And that's one complete turn there. Now, all these, because of this thing I spoke about earlier with the idea that when there's a current flowing in here, there's also a magnetic field in here that tries to oppose you turning it, means that these are actually harder to turn. And if you were to somehow break the circuit, it would be easier to turn it because then there is no magnetic field created because there won't be a current, right? If it's not a complete circuit, you're not going to have a current induced, you're just going to have the potential difference. No current means no magnetic field around this, so nothing to oppose the change, right? So that's why I've said here, these are hard to turn because the magnetic field created in the coil opposes the change, so opposes you turning it, right? But again, this is the 3 points for both of them. You need to learn those words, and then alternator doesn't really have anything else, that's just it, but there are brushes to prevent the wires getting tangled, whereas a dynamo has to have this every half turn, and this is what came up on the 2023 paper, so twice maybe, I don't know. Right, last one, the next one is using this to create a microphone.